Welcome to our lessons on partial differential equations. We continue our lessons on Fourier series, and in this video we're looking at symmetric function, odd and even functions as well. Let's start with the symmetric functions. If you recall our lessons on lines of symmetry in geometry lessons as well as a line of symmetry in linear transformation, you realize that the following are conditions to test for symmetry of functions. 1. A graph has symmetry with respect to the y-axis if whenever xy is on the graph, so is also the point negative xy. In other words, a reflection on the line y-axis, xy becomes negative xy. A graph has symmetry with respect to the origin if whenever xy is on the graph, so is the point negative x, negative y. This is like an anti-clockwise rotation of 180 degrees. So it is symmetric with respect to the origin. So that means it is rotated about the origin clockwise or anti-clockwise rotation 180 degrees. And the last, a graph has symmetry with respect to the x-axis whenever xy is on the graph, so is the point x negative y. In other words, the reflection on the line on the x-axis, xy becomes x negative y. So this were the three things that we know from our knowledge in linear transformation or geometry lessons. Now let's consider a graph of a function of sine x and then graph of a function of cos x. So f of x equals sine x, g of cos x. If you put these graphs together, you can see that the red line here is a cos x and the green dotted lines is the sine x. Now you can see that if you pick the y-axis, the cos sign is reflected on the other side. But if you pick the the g of x, that's f of x sine x, it cannot be reflected on the x-axis, on the y-axis. And both of them does not reflect on the x-axis. We are going to demonstrate that using GeoGebra. Okay, so let's look at the GeoGebra. This is a function of sine x, and I've created a function. I created a slider that will rotate this function f of x equals sine x about 180 degrees anti-clockwise. So if I drag, you can see that the function is rotated, and then it goes, by the time it reaches 180 degrees, it's exactly on the same function. So it's rotating about the axis. So about the origin. So the only part that doesn't move is the origin, it's fixed. So you can see that the function rotates about the origin. So x-axis is symmetric, sine x is symmetric with respect to the origin. Now if you pick cos x, it is not same. If I decide to move it, you can see that when it comes, it doesn't fit. So if I move it, when it comes back to the normal, it's fixed. But when you rotate it about 180 degrees, it does not fit. So cosine is not symmetric with respect to the origin. So that's, but now let's take the cosine with respect to the transformation along the x-axis. You can see that if here I have reflected on the line y equal to either negative 1, 0, or 1. So you can see that as I move from negative 1, the cosine function moves. It only fits into the curve when we are exactly at the y equal to 0, which is the x equal to 0, which is the y-axis. X equal to 0, which is the y-axis. So that's where it fits over there. So that means that it can only be symmetric about the y-axis. So we can also check the graph. We realize that the half from the y-axis, the half here, is exactly the mirror image of the half here. So we said that the function is symmetric with respect to the y-axis. But the function sine is never so. If you check, sine will move out. But sine is symmetric with respect to the origin, and that one it will fit. You can see that it will come and fit. So that is the meaning of the line of symmetry in case of this. We realize from the GeoGebra illustration that the graph of f of x, because sin s is symmetric with respect to the origin, and the graph of g of x goes to cos s is symmetric with respect to the y-axis. So let's consider these functions here. F of x equals to tan x. We realize that tan s is given by this. Now the graph of tan s is symmetric with respect to the origin. You can see that if I rotate this, it will come back and fit. But if I reflect, this one will go here, this one will go here. But if I rotate, this will come back and this one will go and fit here. So it's symmetric with respect to the origin. Now let's look at even and odd functions. Let's start with the even function. We say a function f of x is even if its graph is symmetric with respect to the y-axis. So I hope you remember that. Symmetric with respect to the y-axis. A function f of x is even if its graph is symmetric with respect to the y-axis. Another way of saying is the mathematical is that f of x is even if and only if f of negative x will still be the same as f of x for all x in the domain of the function f. So when you compute a negative value of it, you still get a positive answer as if you computed a positive value of it. Examples of functions which are even are cos x sec x1, that's 1, 2, 3, they are constant functions. X squares, x to the power for all even powers, x raised to the power 6, 8, 10, 12 are even functions. So let's use this one to test what you are talking about. So pick the first one, example here. We want to find out whether this function is even or not. The ideal way is to compute f of negative x. By virtue of this definition, you are going to have negative x squared plus cosine of 2 times negative x. If we simplify this, rather negative x squared is x squared, and cosine of negative 2x is the same as cosine of 2x. So I can say that f of x is equal to f of negative x, and therefore the function is even. Let me use another way to show you this. Let's assume I'm going to let my x equal to 2, or let's just say pi. If I let my x equal to pi, that means my negative x is equal to negative pi. So I'm going to look for f of pi. If you put pi here, you're going to get pi squared plus cosine of 2 pi. And you know cos 2 pi is positive 1. Because you start from the top and go by ends at the top. So that's going to give us pi squared plus 1. Now we compute f of negative pi, and that will give us negative pi all squared plus the cosine of negative 2 pi, because pi is negative. And you know that negative pi all squared is pi squared, but if you use a calculator to compute cosine of negative 2 pi, you realize that you're going to get the same answer as 1. So we say that the function, this very function, is an even function. Now let's look at this one too. Let's choose values like 2 and negative 2 and put them in. F of 2, according to this value, you get this. F of negative 2, you get this. And these two values are entirely different. So we are saying that this function, f of negative 2, is not equal to f of 2. This function is not even. The function here is not even, because for it to be even, that one should happen. And we can test from the general point of view. If you compute f of negative x, you are going to get this, and this is going to give us f of x squared minus sine 2x. Now let's look at this one. If I put 3 and negative 3, you are going to get f of 3 to be 16, f of negative 3 to be 4. So the two are not equal, so the function is not even. And the same way, if I use this notation, basically we normally use this one. This is more preferred for general case. So this will be x squared minus 2x plus 1, and therefore we can see that f of x is never equal to f of negative x. So the function is not even. The last one here, if you put the 2 and the negative 2 in there, you realize you're going to get f of 2 to be 17, f of negative 2 is 17. So I can say that f of negative x is equal to f of x, and for that matter, and so the function is even. So if I want to prove from a general point of view, I'm going to look for f of negative x, which is going to be negative x raised to the power 4 plus 1. And we know that when a negative number raised to an even power, it becomes positive, so x raised to the power 4 plus 1. So I can conclude that f of negative x is actually equal to f of x. Therefore, the function is an even. Let's go to odd functions. We say a function is odd if its graph is symmetric with respect to the origin. So it's symmetric with respect to the origin. In other words, f of x is odd if and only if f of negative x is negative f of x. So, and it is defined for all the domain of f. So example, sine is symmetric with respect to the origin. We know that from the symmetry. So it is all tangent was the same. And all powers of a function, x cubed, x to the power 5, x to the power 7, they are all odd functions. And you should also recall for the fact that a function is not even does not also mean that the function is odd. We have already made that statement clear. So some functions are neither odd nor even. You have to keep this in mind so that you don't make that mistake. So let's verify which of the following functions are odd or even. So let's start with f of x equal to cot x. We don't forget that cot x is the same as cos x over sine x. That will help us to see clearly. So I want to just compute f of negative x, and that's going to give us cot of negative x. And if I want to simply put it the way we can easily see, I'm going to say cosine of negative x over sine of negative x. We know that cosine of negative x is still cosine of positive x, but sine of negative x is negative sine x. So technically we're going to have negative cos x over sine x, which is the same as negative cot x, because cot is cos over sine. So here I can see that f of x, negative x, is actually equals to negative f of x. That is, if you negate this, you get negative of this. So the function is odd. This very function is odd. Let's look at this. The same thing. You're going to compute f of negative x, and you're going to get negative x all squared plus negative x raised to the power 3. Negative x all squared is x squared, but negative x raised to the power 3. You know that when a negative number raised to an odd number, it becomes negative. So you're going to get negative x cubed. Now we realize that this x squared minus x cubed is actually not equal to negative of x squared plus x cubed. In other words, f of negative x is never equal to negative of f of x. So this function is not odd, and it's also not even, because for it to be even, f of negative x should be equal to f of x. So the function is neither odd nor even. Let's go here and check 2. You compute f of negative x, and that will be sine of negative x plus cosine of negative x. And as usual, we know that this is negative sine x, but cosine is still positive cos x. And we realize that the negative sine x plus cos x is never equal to negative of the whole sine x plus cos x. Because if you open the negative sign, it will be negative, which is not negative negative. So that implies that f of negative x is never equal to negative f of x. And it's also not equal to f of x. So this function 2 is neither odd, so it is neither odd nor even. So like we said, some functions can not be either of them. Let's look at the last one. So you compute f of negative x. and that will be negative x to the power 4 plus 3 times negative x squared. This is an even power, so it becomes positive x to the power 4. And this is also an even power, it becomes positive x squared, so it becomes 3x squared. So here I can say that this one here is equals to this. So I can see f of negative x is actually f of positive x. So the function is even. So these are some few trial questions for you. Thank you for watching.